Okay, so this is going to be our second video for Unit 4, Day 1 of Algebra 2. And in this video, we're briefly just going to talk about what exponential functions even are. And we're given the basic format here, right? In your standard form, exponential function isn't going to quite always be so simple. Okay, so let's go ahead and say the parent function for this would be some base to the x, right? And depending on what this base here is, that's going to tell us if this is a function that exhibits exponential growth or exhibits exponential decay. We'll get into that in the next video. Okay, but this is just like what we saw in the previous video where we talked about exponential regressions. So we had f was equal to 3 to the x power, right? And we know that that's true because, well, if we calculate f of 0, well, that would be 3 to the 0 power, which of course is in fact 1. If we do f of 1, that would be 3 to the first power, which of course is just 3. If we do f of 2, that would be 3 squared, which we do know is 9. And if we continue and continue and continue, right? So 3 to the third power, that's 27. 3 to the fourth power is in fact 81. So these are exponential functions. Okay, our function of x, this is our actual f of x, our function of x is up here and is an exponent, hence exponential function. Okay, so here's another example. Um, we don't have a whole lot of information here, right? But we have enough to work with, right? So let's say y of x is equal to some number a times 0.8 raised to the x. Okay, so right here, where we have b to the x, b this time, because b is less than 1, we say that this is exponential decay. Okay, this means that we're getting smaller in terms of magnitude. Okay, and we're getting smaller effectively by 80% for every increase of x by 1, right? So every time x goes up 1, we're getting 80% smaller by that exponential factor. Okay. So let's go ahead and just work through this to kind of get an idea of what's going on, right? So what is the value of a? That's the first thing we're asked to calculate. And we know that it's in this format. So all we have to do is plug in for this value of x and y. So I am going to say if x is 0, right? So that would be equals a times 0.8 to the 0 power. When x is 0, then y is 64. Okay, so there you have it. Y equals a times 0.8 to the x. And I've substituted for everything there, right? You'll remember that anything to the 0 is always 1. Okay, so this effectively becomes a times 1 equals 64. And anything times 1 is just itself, and we're done. So a is 64. Okay, so now that we know that, we can easily complete the table. Okay, and I'm going to try and figure out what color is going to show up best, probably red. Okay, so let me change that. That's just going to bother me. Okay, so if we're going to complete the table, well, now we have the full function. Y of x is undoubtedly equal to 64 times 0.8 raised to the x power, right? And of course, we know y of 0, right, was 64. That's why we have this here. Okay, but what about y of 1? Well, that's going to be 64 times 0.8 to the first power, right? So that's just going to be 64 times 0.8. Okay, so if I just go to calculate here, so 64 times 0.8, and that's just going to be 51.2. Right, and we could keep going this way, only this kind of sucks. Why don't we use our graphing calculator to work smart here? And that's exactly what we're going to do. So I'm going to do 64, open parentheses, 0.8, close parentheses, raised to the x. hit enter, and then we just simply hit Control T, and it's got everything for us. So when x is 1, well, duh, 51.2. When x is 2, 40.96. Okay, when x is 3, 32.77 about. And when x is 4, right here, 26.21 about. And we're finished. Okay, so in a nutshell, that is precisely how exponential functions work. If you have any questions about exponential functions or anything like that, and this was a really basic example, but if you have any questions or need anything more in depth, obviously you know where to find me or shoot me an email. Goodbye.